Hi everyone, so here are your 0.4 point four notes. These cover rational numbers and their opposites. So something to keep in mind is that dividing a whole number in a particular way comes up in a variety of situations, from cutting a cake to distributing an estate, and the resulting shares can be described with fractions. What begins simply as a quarter or half can quickly become more complex as we work with the subtleties of fractions. This section will explore the notation used in fractions and its multiple meanings. We will use that notation to develop the procedures which you will have likely encountered before. One goal for the section is to understand why the fraction rules work as they do. Another is to know how to use them in a variety of ways, including with signed numbers and mixed numbers. So as you work through this section, think about the following questions. Do you know how to read a fraction in a meaningful way? Do you remember the rules for adding and multiplying fractions? And how do the rules for integer computations from the previous section apply to rational numbers? So a rational number is any real number that can be written as a quotient of two integers. While rational numbers can be written in either a fraction or a decimal notation, there are three common ways that they are interpreted: a number of equal parts of a whole, the ratio of two integers, or a number on a number line. So if you look at these are the following ways that we can interpret those. We can think of it as 3/5 or 3 parts out of 5 total parts that make a whole. 3 out of every 5, because this, if we think about it, it's for every 3 out of every 5. So they just kind of simplified 6 out of every 10. And you can also think of it as 0.6 on the number line, being between 0 and 1. Some important vocabulary is that the numerator is your top number and that the denominator is your bottom number. Two different illustrations for the meaning of 7/4, and I'm actually going to have us change this to 4/7. And I think that we'll be okay with just one representation. So if we think of this as almost like a candy bar, we can use our denominator to tell us how many total pieces there are in the candy bar. So we would have 7 total pieces in the candy bar. So if we count, we've got 1, 2, 3, 4, 5, 6, 7. If we have 4 out of the 7, our numerator tells us how many of those pieces that we're actually considering that we have. So this would be 4 out of the 7. Okay, so that would be our representation of 4/7. Some fraction operations require that we can write an equivalent fraction. The part of a whole interpretation is useful for understanding this process. So when we think of looking at this as 1/3, if we split this up into more pieces, we can see that 2/6 still represents the same amount of area. Therefore, we have equivalent fractions. One rule about equivalent fractions is that we can make them by doing one of the following. We can either multiply or divide the top and the bottom by the same value. So we have to make sure that we do it to the top and to the bottom. So what they did in this one was they multiplied by 2 on the top and the bottom, and they got 2/6. And they were able to even bring it back to 1/3 by doing the same, but dividing instead. Okay, so we're going to rewrite the fraction in each of the following ways. This one tells us that we want the denominator to be 60. So I'm going to take 22 over 30, and I'm going to then change it so that the bottom is 60. So I'm going to ask myself, because in order to change it to an equivalent fraction, I'm going to ask myself what I have to multiply or divide by to get from 30 to 60. And it's okay if you guess and check with this. So we can see that we would multiply by 2. And if I do that to the bottom, then I also need to do that to the top. So I get 44 over 60, which would be my final answer. This one says we're going to switch it to actually be a numerator of 88. So for this one, we're going to start with 22 over 30, and we're going to change it so that it has a numerator of 88. So we want the top number to be 88. So I'm going to ask ourselves, what are we going to do to change it from 22 to 88? And it's okay to guess and check a little bit. We would multiply by 4. So I want to do the same to the bottom. So 30 times 4 is 120. So as an equivalent fraction, that's what we get. To put a fraction in the simplest form, we are going to take out any common factors that 22 and 30 have. So the easiest way to do it is to just divide by 2 for this one, and we would get 11 over 15. There are no other common factors that go into 11 or 15, so that's all that we need to do. An easy way to do this is also to just use your calculator, and you would just type in the fraction just like this to start with, and then you would just press enter and it will give you the simplified fraction. Your calculator will do the work for you if you let it. One thing that you'll see for your calculator, if you have a scientific calculator, the fraction button usually looks like n over d, or it can look like some blank spaces with a fraction, or it can look like a and then b over c. So those are usually what the fraction calculator ends up looking like on your calculator. So for operations with fractions, at this level of class, I do not want to spend a lot of time working out how to add, subtract, multiply, or divide fractions. Instead, at this level, I want you guys to just be able to type it in your calculator. So I'll go through the steps of how we would type it in our calculator. For this, we would use our fraction button, and we would use 3 over 10, and we would write it as a fraction. And then we would write our plus sign, and then we would use our fraction button again to write 7 over 20, and then we would just press enter, and we will end up with 13 over 20. The calculator will do the work for us. So you can go ahead and try B, C, and D the same way. I'll pause the video and then have the answer show up. Okay, so that's what we get with these questions. Your operations for multiplying and dividing fractions will be done the same way with your calculator. You'll just use the multiplication or division button instead. So if we look at example 4, we'll do these the exact same way with our calculator. Again, I'll pause the video and then have the answers revealed. Okay, that reveals our answers for example 4. Looking at example 5, it says, let's do these next few problems to learn how to check for equivalent fractions. There are 2 ways to check for equivalent fractions. The first one is to cross multiply. If they are equal, if the products are equal, then they are equivalent. If they are not equal, then they are not equivalent. For option 2, you can divide to get decimals, and then compare. they do need to be the exact same. They can't just be close, they must be the exact same. All right, so looking at option 1 here, I'm going to go ahead and cross multiply. So I'm going to multiply the 3 with the 16. I get 48. Then I'm going to multiply the 8 with the 5. And I get 40. So these are not equivalent because they do not match. If I wanted to use the decimal method, I can just take 3 divided by 8. So I would just do 3 divided by 8. And as a decimal, I get 0.375. And if for this one I did 5 divided by 16, I get 0.3125. Okay, looking at part B, same methods here. We're going to cross multiply. So I'm going to do 5 times 81. We get 405. And then I can do 45 times 9. So 45 times 9 will also get us 45. So we can see that these are equivalent. They match. The other way to do it would be to check the decimals. So if I did 5 divided by 9, you only need to do one of the ways. You do not need to do both. It's 5 repeating over and over and over again. And 45 divided by 81, I get 0.5 repeating over and over and over again. So also this shows that these are equivalent. We will not be working with ones that are mixed numbers where you have a whole number with a fraction. We do not need to worry about that for this section. So that wraps up everything for section 4.